So welcome class. This learning video is really aimed to help you move through the Nvidia content a little more expeditiously. And so in this one, you see that I've created I clicked the link and it was in the assignment, and I clicked the launch button and it came back with 1 hour and 52 minutes. I know that some people have had trouble with it running out in 2 hours, but the key to actually not getting into that trouble is to have gone through the lab, to look at all the slides NVIDIA provides. In the back of this deck there's many slides. Also, when you click the launch, it opens up a Jupyter notebook, and you can see Jupyter notebook here. I can't emphasize enough that you need to actually read this. If you read this, there's 2 pages to it. Open Digits actually opens up the Digits program. We'll come back to that. And it tells you an awful lot. If you like page 1, page 2, and it shows you how to do things. Then you continue to the next notebook, and the next notebook opens up the 2nd page of the instructions, and it goes through and it explains a little bit more. Talks about neural networking and everything. This is actually pretty important. And then we go through all these. I mean, I know that people always just like want to get the mechanical part done, but you need to take a moment to learn this. I mean, the mechanical part is just gooey in that regard. So I mean, it's fine, but it's not about learning mechanics of copying and pasting. It's about understanding that artificial intelligence and deep learning algorithms can help you identify things, and you can tune models to get great. So if you read this, it's only 2 pages. You can see what it is. Now the appendix is the inverted data set. I recommended to everybody use the inverted data set. So in the assignment, I have provided actually in here you also see the Caltech data set right here. So actually both data sets are right here. So the first thing I recommend, just mechanically to get this done, just take it easy and do it mechanically, is to copy and paste both data sets into Word. If you think about it, you're going to be creating 2 models. One model based on the digit, which is the inverted data set, which is all about digits. The second one is going to be the Caltech one. So basically there's 2 models that you're going to go through to grab and to actually run your simulations. So I like to put both models here. I'm just very systemic that way. Now you can just carry this and just do one at a time and just do digits and get it all done and over with, and it wouldn't take very long. In fact, it's going to take as long as this learning video. But Caltech, it's the same problem, right? You're going to start with Caltech, you're going to process it as well. So you already know you have to create 2 models, so why don't you just import both data sets? So the way to do that is to make sure you copy the digits data set, and you do that, and you go back in and you look for the digit start program. So it said open digits somewhere in here. There it is. And there you open digits. Like I said, there's 2 data sets. So let's bring them in. Images, classification, username Chris, submit. First data set's right here. Pasting the digits. This is the training data set. So you're going to load the data set and then train, right? So in percent for validation, and you want to tune your model. This is one of the areas that you tune your model. Give it a group name. I like digits. Digits. I don't want you to overthink it. Create. Keep it all lowercase and those kind of things. And you see it just loads the data set. And let's wait and see when it gets done. You can see the time percentage here, how long it will take the NVIDIA server to load it. Now note that the NVIDIA server is a virtualized server, and that virtualized server actually has it's not on your PC, so all the work is being done on there. So what they do is they virtualize a session for you. So when you look about creating a lab, what it's doing is creating a sandbox for you, or virtualization, like a little work environment, a workspace per se. And in that workspace, you're able to do things. So let's just wait for it. Maybe what I can do is It seems like it's running slow. Maybe it's doing a backup. Usually this is a pretty quick one. Create database train running. So I'm going to put this on pause while it loads this data set. We'll go from there. So as you see, we're almost there. It actually wasn't very long. It was just a couple of minutes. The top one seems to be going slow, but this create DB here on the bottom, the validation one, it seems to be running pretty quickly. So let's see what goes on there. At 87%. It started at 9:14, and now it's 21. Created validation DB. So you notice what it's saying. So read the messages. The training DB, the validation DB. So you read the PowerPoint and it talks about the need for validation and need for training. It has to have a training database, a validation database. You're going to test it. It's going to run through Epoch all the way that goes through. Look up what that word means and those kind of things. Well, how exciting. Look at that. Is it 99? Boom, database created. That's not so bad. It's still running a training database, but that's okay. Export a DB, click on it. These are the digits. Remember, it's the inverted data set. It has both. It's got the black letters on white background, white letters on black background, so it's inverted. You have both sections. So it's actually a more robust data set in that regard. Hit the back button. That's pretty good. I think. 13 minutes. Let's see if link a new tab. I don't know if we can do that. Ooh, it did open. No data sets yet. Images. I'm doing two at the same time. I don't know if we can do that. Let's do it. Let's go over to the Word document where I pasted both links. I've got this Caltech database. Copy this motion. Oh, that's a model. Oh, back, hit back. I don't want a new model. I want a data set. Digits is running right there. See it? Images, classification. Copy and paste the model, same kind of thing. Percent for validation, percent for testing. In that regard. You tune these to get to where you want it to work. This is Caltech. They're cool images in Caltech. I really liked what they did there. Hit create. And voila, it looks very similar to the other process. We go in, it's parsing it, creating a training DB, creating a validation DB, and it's going to actually spin this off and work. So let's let both of these actually get this. There it goes, it started. I got trouble, taking some time, loading some things. Sometimes it's faster than other times. It depends. I think the people in Europe are probably using their servers. There's only limited free resources when you actually use people's supercomputers to do things. But that's okay. At least it didn't cost us anything in that regard. So here we're doing the Caltech one. Oh, look, great to be. Now this one's flying in only 4 minutes. This is a bigger data set. How funny. Let's let it go ahead and continue on. We'll be able to zip through this one pretty quickly. And you can see you got a tag. It's 1 hour and 38 minutes left. And those kind of things. But this one's like literally almost done. Digits was slow today. But this one is not slow. It does vary by hour of the day. That was super fast to create a validation. It's on the 23-minute, 9. They swear it could be running in the Caribbean. Is it the 25 mark now? So 2 minutes to create the validation. But you see, the other one is done. This one is flying. The Caltech is really loading quickly. We'll be able to share this one. Just keep running it, brute force. Go back to digits while it's loading. It doesn't seem to be working very much at all. I might have to reload that one. Or maybe I'm using the capacity because I'm saying I never actually did 2 at the same time. Let's see how it goes. This is pretty cool because we're going to actually be able to load it, but I want you to see what it is. It's important when you test your models to go ahead and know the images. You have to look at the images. That's why you look at images of digits, and you're going to test your 3 files that you upload. You need to actually test the 3 files that you upload. I think that's really important. If not, you're going to be uploading. If you're training a computer to look at digits, and you upload a picture of an apple, you didn't train it on what an apple versus orange is. What you did was train it on what a digit is. So you got to make sure you know what you're training on. That's really important. It's simple that if you train a younger person or a child on how to do something, they won't necessarily know how to do something else because you didn't train them on that. So it's very similar in that regard. And this job is done in 3 minutes and 45 seconds for Caltech. Wow. Okay, well that's pretty impressive. Oh, look at this. The other one's 89%. We got the one data set, so let's see how that goes. 90%, so it's moving along now. Very strange. I think it's moving faster than what the update is going. So it didn't actually take as long as I thought it was going to take. Let's give it a minute and you'll have the digits database. Total elapsed time so far, 135. It's at 92%. You just wait. Remember, I'm loading 2 databases to do them both at once. It's important to point out also, you're loading up in a lot of images. There's almost 5,000 images here per data set, and some of them, the Caltech is actually more complex than you have the digits data set. So you're loading up almost 10,000 images. That's a big file, though. If you took 10,000 pictures and had to load them somewhere, in their whatever size they are, it takes a little while to process those images. And here you're asking a computer to load them and analyze them and train them and validate them. So it's actually doing quite a bit. It's not just copying and pasting images, or not sharing them. It's actually exploring them on a digital basis. So here you see we have the 2 data sets. You click on it. We've created both the Caltech and we've created the digits data set. Now we want to create a model. Remember each model. So you're going to be everything containerized. You're going to have a digit model. You're going to have a digit data set. Merge the two. You don't mix match something. Like if we're teaching somebody something, you want to teach somebody how to drive. You don't teach them how to drive and then ask them to, can you swim across the pool length? Because there's two different activities. You didn't teach them how to swim. What you did is you taught them how to drive. So you have to keep everything in its logical buckets, right? You may teach them how to swim the next day, but in this day you taught them how to drive. Images, classification, pick it. The first one is let's take digits, because we named it digits. And if you go through training epochs, that's an awful lot of epochs. I'm just probably going to make it 5 to keep it simple. And you pick the different ones here. I think AlexNet is probably one of the higher performing ones. There's papers, you can read a paper at each neural network, a deep learning network. I think AlexNet is probably the most productive. Group name, digits, model name, digits. There's 2, we want to keep it, hit create your model, and then this creates the whole model. I think I showed this in class previously as well. First it said 5 hours, now it says 29 minutes. It's kind of crazy. This is the loss ratio. These are like live charts. You can hover over them while they're producing, and you can see where it goes and where it doesn't go. I wonder if we can actually do 2 at once. Click a new tab, and we can go to models, images, classification, Caltech. Also, I don't want to do a lot of epoch in here. You can play with it and do more and more to get your desired percentage, but not necessarily up front. AlexNet, Caltech. Weird. Is the Caltech database. I went with 4 epochs. Probably the right number to go with. I'm just doing 6 time. It's probably about 7 epochs. It will probably work for both models, 7 to 9, to achieve it. You can play with multiple iterations, do it higher, try to get to optimal percentage. It's important to note that Caltech database is more sophisticated than the digits database, so there's more images there. So you may have to run some more epochs to get it to work. Status waiting. Oh, it won't do 2 models. How interesting. Well, this one's running along now. So it's got this first epoch complete. Look at the loss ratio is dropping so quickly. When it first started off, I didn't know what it was. After I started running through the database, it identified what they were. I started producing them pretty quickly. I could have wrote digits model to have been a little clearer. My naming. What if this? We already know this is done. So we go back to digits. We go to Caltech. And you see all the stats and how long it took to build and everything else. Yeah, I want to go to Caltech. So here we are, waiting. One of the things to think about, if you look at this database, there are 90,000 images. The inverted database was much larger. Like, I don't know, in this case, it was 20 times larger than a smaller database that they point out at first. I used the inverted to get a better, richer picture, get more accuracy. So it certainly had an amount of pictures that had both on it, black, white down. had a white background. So I wanted to get both, how people would draw numbers, and we had those two different things. So it took quite a bit to process this image. It's just a really large one. That's why my data set's taking so longer. You saw that the Caltech was only a lot less images, and when this one's running, it's got 35 seconds left. The Caltech is still queuing, waiting to go. But look at the Caltech, it's only got 68, 66 loaded to training database. So it's a much smaller data set. So let's watch how fast or slow the two databases will go. Of course, the more images you load, the better your models will be, the higher percentage of accuracy it will be. While you're waiting for those, I opened another browser and I started loading images, right? So digit images on black background. I had before then digit images, various backgrounds, white or black. Then I put Garfield, because I saw the second data set actually had Garfield loaded to it. And then I did an airplane image. So take advantage of this time, right click on it, save image as. Save it as JPEG in that regard. And that's a good thing to prep. You need to do 3 of them for this exercise. So you might as well go ahead and get the images done while you're waiting to do it. Let's see what this is. This is the Caltech database. And you can go into Caltech database and export a DB. And you can see all the different pictures in Caltech. These are more sophisticated pictures of people, faces, affirmations. The dog looks not happy. I guess if you're taking a picture of the dog, you get multiple images of that. And so you can train this database. And it's only because you saw it had 6,000. There's a catch as a sailboat. So the students at Caltech that created these databases really did a fabulous job of collecting a random amount of images. Let's go back. See Caltech. And we got that going on. Which one is it? Oh, the Caltech model is flying. Look how fast it's going on Caltech. Because we already created the digits model. Now we have the Caltech model. Here's the digits model. It gives the loss ratio. Look how high it, because there were so many images, one epoch that went through 90 of them, it was already at 95%. It didn't really improve too much from there. So actually one epoch was more than enough for the whole model to go through. I think we did ask it to do 5, so I didn't need to because there were so many. If you take a smaller set of pictures, you have to run more epochs to make it work. Upload image. Images. This is numbers, right? Number 6, and then you upload it. And you hit classify 1. And you do this 3 times. And let's see if it will work. Might not work because I'm running the other model. Oh, look at that. It did work. And there's a 56% likelihood that was a number 6, but it was actually pretty right. Although the likelihood was, I guess, the way they drew the 6. There was multiple colors, so it didn't understand. But still, at the end of the day, it caught to classify 1. So that was nice. And then you can go back to digits, and you can actually upload another one. You saw that I had done number 6. Then you have number 2. See how it does on that one. Classify 1. Ah, 99% likelihood too. So nice clean 2. Went through. There are 2 very different images, 2 very, very different outcomes. How do we do here? Well, that's not that. Let's see. Are we still running? Is it Caltech model? Yes, it's a model. Let's go down and train models. Browse the images. Of course, you need to take, here's the Garfield image. Classify 1. Let's see if it recognizes Garfield. I think I saw that in the data set. No, it did not get Garfield. I thought I saw it in there. That's how sad. I thought it was going to get Garfield. See, more sophisticated model. Let's try another one. And maybe I'm wrong. Maybe there wasn't a Garfield in there, but I thought there was. Upload an airplane. Let's see if it classifies an airplane. it's having a problem, maybe because of the background and everything. It can't really differentiate the object in the middle versus the noise that's getting from otherwise. Let's go back into the digits here. Let's go into the Caltech database. Let's take a look at the, oh, not the model. I want to go into the data sets, Caltech, and actually explore the DB. Motorbikes, it definitely had motorbikes. Maybe I didn't have those images in there. See, I might ask it to do something that didn't exist. Motorbikes. So what it does is to the image, and it tells them what the image is, and then it learns to do it. That's called supervised training. Let's copy this. Let's go over to our images. Type in motorbike. Take an image of a motorbike. I don't know. Any of these would be fine, I suppose. Save image as. I thought there was Garfield in there. I was kind of surprised. So we save the image. Go back to our other browser here. Which classify one. Oh, classify another. Oh, this is the, yeah, we have to go back to digits. Go back to our models. Go back to Caltech. Upload an image. Get a motorbike and see what's going on with the Caltech one. It's definitely working. It just doesn't. Let's see if it'll recognize the motorbike. Ah, that it did. So there's a perfect example of how to run it and do it. You do it 3 times and you can tell that the model is pretty darn accurate. What did I do wrong? The airplane it should have caught. I don't want to actually understand why it did that. When I went to Caltech and I started looking at the images, maybe I didn't train it well enough. I needed to add more. It had airplanes, so it should have recognized it. And there's background noise in the airplane. So maybe that was just not a good image for quality. Maybe the pixels were low in that regard, so you just get another one. There's plenty of those. Like, yeah, here's one, the images. Copy image address. I think I can do that too, can I not? Image path. Clear this because I don't want to upload it. I don't think so. I get confused. I will do the path of a bike and a thing that's going to err. That's like one image. I knew it. I had gone through too much. Tried to do it too many times. So you actually do, finally, one of my keys are being sticky. It's my computer. Anyway, that's how you do it. The important thing is these things are interactive. You can tell what the loss ratios are. You see the Caltech is not able to get a bearing on it. So it was a good exercise. We did it. Let's go back and see. 1 minute, 4 seconds, 56 minutes, and we ran both sets. That's what it takes for the assignment.